Our Earth is bejeweled with amazing panoramas, colossal water masterpieces, majestic mountains, fiery volcanoes, and vibrant evening skies. These are all different facades of the Panch Tattvas, the basic elements that we are eternally connected with. We are often enthralled and humbled by the wonders of Mother Nature. All these marvels are easily accessible to humankind as they exist on the terrain. But nature also reveals its divine form in the vast interiors of the ocean, which is 3 times larger than land. In fact, the immense ocean contains a bounty of diversity which far surpasses that found on land. And one of the most picturesque creations of the deep is the coral reef. It exhibits extensive biodiversity in structure and form. Coral habitats are usually shallow water, highly diverse, productive, and act as fish breeding grounds. These stunning ecosystems have always attracted people's attention for leisure and tourism. They have also attracted the attention of researchers due to the exotic marine life that exists around them and offer fascinating opportunities for scientific studies. Corals are some of the oldest life forms that have been existing on the planet for millions of years. They exist on the Earth by building limestone reef structures fast enough to keep up with their erosion. Reef building is a result of biological precipitation of calcium from seawater by certain calcareous organisms, which include foraminifers. The scleractinian or hard stony corals that live in colonies are usually associated with the shallow water tropical limestone reefs. The reef formation is a collective work of countless polyps and requires a lot of energy in the form of sugars and other biomolecules. To fulfill these energy requirements, corals form symbiotic relationship with the dinoflagellate algae from the genus Symbiodinum, which are collectively called as zooxanthellae. It resides in the tissue of gastroderm of the coral polyps. It is estimated that zooxanthellae transfer 90 to 99% of its photosynthate to its host polyp. Coral reefs are among the marine systems with the highest photosynthetic rate. Zooxanthellae need light for its photosynthesis, and so the coral zooxanthellae symbionts are restricted to aphotic zone. Crystal clear, shallow tropical waters where the temperature is at least 18 degrees centigrade, with the optimum temperature range from 23 degrees centigrade to 27 degrees centigrade is required for corals' growth and reef formation. They dominate shallow tropical environments between the latitudes 25 degrees south and 25 degrees north. Reefs grow best usually where the average salinity is 36 ppt and where there is little or no sedimentations from river runoff. These ecosystems are also known as complete ecosystems, as they sustain various kinds of marine organisms without giving out any waste, and are also considered as ecological hotspots due to their vulnerability to climate change and human intrusion. Coral reefs are not found everywhere in the world, but concentration of these are present in a few restricted spots only. In India, the coral reef ecosystems are restricted in the main 7 regions: Kerala coast, Goa coast, Gulf of Kutch, Lakshadweep Islands, Gulf of Maner, Polk Bay, Andaman and Nicobar Islands. One recent discovery of such a location that hosts this particular type of ecosystem is Angria Bank, a shallow underwater plateau off the central west coast of India, where amateur divers have found an underwater paradise.
In India, we have two kinds of coral reefs generally. We have corals in Andamans, which are basically fringing reefs, and then we have extensive corals in the Lakshadweep. These are coral atolls. We also have some patches of corals both along the west and east coast of India. But in addition to these major coral reefs, we also have what we call the submerged reefs, which are also called the banks, and these were islands at some time, about 10,000 years ago, when the sea level was lower. But this coral growth still occurs in this, and one of the most important banks in the Arabian Sea is the Angria Bank. And this is one ecosystem that had not been studied so far. And this institute has taken up a major study to investigate the biodiversity and the biogeochemistry of this ecosystem.
Angria Bank, located 120 nautical miles northwest of Goa, is a submerged reef known for coral diversity and associated biota. Rising from the depths of 1,000 meters at its base to an average water depth of 20 meters, it is 39 kilometers in length and 17 kilometers wide. In order to assess and map the marine biodiversity in the area, a systematic study was necessary. Hence, the National Institute of Oceanography formulated a multidisciplinary study funded by the UNDP's Global Environment Fund and Government of Maharashtra's Forest Department. The objectives of the study were to study the biodiversity and ecology of the corals and associate flora and fauna, and to identify the anthropogenic threats to the Angria Bank that could destroy the reef system in the future. The initial survey conducted by researchers from organizations CSIR-NIO, CMFRI, and Fisheries Survey of India has indicated the occurrence of extensive corals in this region. Underwater survey conducted by echo sounding and side scans sonar data revealed the presence of prominent shelf edge reef concentrated mostly in the central and southern parts. The reefs were reported to be 1 to 12 meters high and 0.1 to 2.6 kilometers wide. The coral community is said to have started developing after the Holocene sea level rise a few thousand years ago, and the coral growth continues even today. It is revealed from the scientific analysis conducted at the NIO's Donapolo laboratory that Angria Bank harbors exceptionally high diversity of marine flora and fauna. Based on the physical sampling, photographic data, and visual observations, NIO scientists could identify over 200 marine species, which included 56 species coral, of which 45 were hard corals and 11 species belong to soft corals, 12 types of crabs, 15 species of brittle stars, 8 species of gastropods, 6 species of polychaetes worms, 4 species of jellyfish, and over 40 other species, including 9 species of seaweeds. It is very important to note that the present survey covered limited area of Angria Bank, and the list of the species could certainly increase if scuba diving and sampling can be conducted in a wider area. The vessel Sindhu Sadhana, the first research vessel built indigenously, equipped with all modern scientific equipment and dedicated laboratories for sample and data collection of multidisciplinary oceanographic parameters, were used for the survey work. A professional team comprising experienced scientists and experts was connected with this mission. For diving, the research vessel was used as the mothership. A fishing trawler was used as the diving support platform, and an inflatable raft was used for launching the diving operations. Each diving operation required perfect coordination between the teams on all the three platforms, not only to ensure the safety of the divers, but also to accomplish the task of the expedition, irrespective of the weather conditions, which on certain days hindered smooth operations due to high winds, large swells, and choppy seas. A total of 15 dive locations, with 3 to 4 divers, were engaged at each dive to observe and document the biodiversity of the entire bank, including a transect from east to west, which were carried out over 5 different days. At many of the dive locations, sample collection with zooplankton net, sediment and rock collection with grab as well as surface water collection was carried out to assess the associated biological, chemical, physical and geological data. Through the various sampling and echo sounding of this location, scientists have derived a few preliminary observations. Angria Bank has high biological diversity: corals, fishes, seaweeds, and other invertebrates. The seafloor is varied, rocky, sandy, coralline, and seaweed. The edges of the bank are steep. Southern and western edges have more of coral diversity and associated fauna. Eastern and northern edges have more sandy or coralline rocks with fishes. Mankind should conserve and be protective of this magnificent ocean treasure. But unfortunately, man himself is becoming an adversary of this natural wealth.
There are 2 kinds of threats that the coral reefs are facing. One is from the warming itself. The seawater is becoming warmer because of global warming. And the other one is ocean acidification. And this is because the seawater is taking up carbon dioxide from the atmosphere, which is making it more acidic and it's becoming more difficult for the organism to precipitate calcium carbonate biologically from seawater. And therefore, ocean acidification is a major problem globally.
To ensure the preservation and protection of the rich coral diversity that exists on Angria Bank, we are planning a detailed bathymetry survey of the Angria, a biodiversity profiling of Angria Bank, and formulating a geographical information system database bank to identify anthropogenic threats to Angria Bank, and site selection for long-term monitoring of the reef ecosystem. Effective management practices based on scientific principles are required to monitor, identify, and eliminate any physical activities that may exert pressure on the Angria Bank reef. For coral reefs reflect the richness of life under the sea. They are the poetry of the ocean and must never die.